Welcome to Ask and Learn.
If we want to know where we get convergence, we can use the ratio test. So limit as n goes to infinity of absolute value of an plus 1 over an. And then we want for this to be less than 1. And by an, we mean this whole chunk here, including the x values. So this is limit as n goes to infinity, absolute value, and this thing is going to simplify to x minus a, n plus 1 over b to the n plus 1 times b to the n over n. Okay, so there's still some more simplifying to do here. And then this b to the n divided by b to the n plus 1, there's going to be some cancellations happening there. So that's going to turn out to be just 1 over b. And then we still have this n plus 1 over n. As n goes to infinity, n plus 1 over n goes to 1. So this is absolute value of x minus a over b. And as we mentioned, we want for this to be less than 1. So if we multiply both sides by b, then we get absolute value of x minus a is less than b. So already we can probably see that the radius of convergence is b. And we know that because x minus a is trapped between minus b and positive b. So if we take this, we can add a to both sides. And then the length of the interval of convergence is a plus b minus a minus b. So this is 2b. And 1/2 of the length of the interval of convergence is just b, as we were predicting it would be. So remember, the radius of convergence is 1/2 of the length of the interval of convergence. We know that we get convergence for x between a minus b and a plus b. And to figure out the interval of convergence, we just need to figure out whether or not these endpoints work. Okay, so b is our radius of convergence. So now we check to see what happens when x is a minus b. When we plug in a minus b in here, we get n over b to the n. And plugging in a minus b, the a and the minus a will cancel. So we have minus b to the n. Minus b to the n is minus 1 to the n times b to the n. So now we'll get a cancellation with the b to the n terms. So now it'll just turn out to be sum. Let's see, sum from n equals 1 to infinity of n. And as we mentioned, nothing will cancel out with this minus sign. So we'll still have minus 1 to the n, but the b to the n's will cancel. And this is definitely going to be divergent because these terms are certainly not going to be going to 0. Okay, and then similarly, if x is equal to a plus b, if x is equal to a plus b, we plug in x equals a plus b here. A minus a is 0, so we just have b here. So b to the n divided by b to the n. Those will cancel, and we just get sum from n equals 1 to infinity of n. And again, this is certainly not going to go to 0, so we can't possibly have convergence. So again, we get divergence here. So both of the endpoints we will not include in our interval of convergence. So our interval of convergence, we have this open interval here. Open because we have to throw out this point and we have to throw out this point.